So let me briefly review limits for you all. So this should be basically the stuff we just did on the quiz, right? So what I want to get from you guys is, what was the basic idea of what we just talked about like 2.5 minutes ago? So hang on. So let me start by saying the thing I'm trying to define is limit x tending to a of f of x is some value L, right? When does this happen? What does this mean? So what was the whole thing I wrote down about epsilons and deltas just a minute ago?
Let's see. For any epsilon greater than 0.
Yeah, good. Okay, so if for any epsilon bigger than 0,
there is a delta greater than 0.
Okay, so there is a delta bigger than 0.
Such that if 0 is less than the absolute value of x minus a, which is less than delta, then the absolute value of f of x minus L is less than epsilon.
Okay, and what did we say this meant? We said this means that if I have an error in the output, right, there's an error in the input, so that if I'm within that input error, then the output will be close to L.
So I've never seen this, sorry. So how does this relate to a limit existing?
Perfect. This is the definition of what it means for a limit to exist. So I'm going to throw this of epsilon in here, because it should be noted that earlier somebody said, well, what does epsilon, or what does that delta depend on? Probably epsilon. It also probably depends on the function you're dealing with, right? You guys all see that?
Yeah.
So really it's kind of fundamentally a function of epsilon, but it does also depend on the function you're starting with, okay? And the picture that I was drawing for this, right, is we have some function, right, with maybe some missing hole or some kind of funky business going on at a value a. Right? I'm literally drawing the exact same picture I drew a minute ago, right? Where do the epsilons go?
Above and below.
Yeah.
Good, perfect. Those are here, right? So that's my minus epsilon plus epsilon from L.
Epsilons are outputs, deltas are inputs.
And then good. And I follow those over here, and then I follow that down into the input band, right? Or into the inputs. And I say, okay, well, this one's closer maybe, right? So like, here's a delta that'll work. Does it have to be the best possible delta? No, it's just got to get you in there, right? So there's a minus delta and a plus delta there. And then the key here, right, is that this stuff, keep in mind I'm not including A, right? So that's punctured there. When I push that forward with the function, it ends up smeared in here right around L. You guys see that? So this is what it means to work. You guys drew pictures of when it didn't work, but I want to clarify that in one dimension, those only take a couple of forms. Okay? In one dimension, they can take runoff to infinity forms. Okay? So that could be maybe like, here's A, and there's some kind of asymptotic business going on there. You guys have had Calc 1, so you know what limits to infinity look like.
Yep.
Okay, but I want to clarify that even if both of these go up, right, that's a kind of a different thing than this. Right, because the absolute value of something minus infinity doesn't make a lick of sense. So you have to make a new definition for that, right? What's up?
On your y-axis, or I guess that'd be L, you said you had a positive epsilon and a negative epsilon?
Yeah, so the ends of this thing are L plus epsilon up here and L minus epsilon down there.
So the epsilon is like the maximum error you can have, and then you just go in the opposite direction for the negative one? Or
Yep.
do you get that value from something else?
No, so that's just me saying, this is the error I need to be within, right? Like, if
Okay.
I'm filling cans of soda, right? I have some machine that just like pumps soda in there. I would like that to be 12 ounces of soda in the can, right? Okay, but the can's a little bigger than that because it better be. Otherwise I'll spill soda all over the factory floor, right? So the can might actually be a 12.1 ounce can, which means that my fill should be 12 plus or minus 0.1 ounces, right?
Okay, so it's kind of like an absolute value where you can go like.
Yeah, exactly.
Same value in either direction.
And then the input in there might be how long does the valve stay open for? You guys see that? So that's a like time error makes a Coca-Cola error, right? And so I'm interested in how much time can I allow that flutter, right? Like how much can that timer be off before I'm spilling Coke all over the ground? You guys cool with that as an analogy?
So epsilon and delta, it looks like they would depend on the function, because you could kind of.
Yeah, they definitely depend on the function. Yeah, this whole thing definitely depends on the function and also this value that you're approaching. Cool. I want to highlight another way that limits can fail to exist, which is maybe this thing.
Lots of them.
If you have some kind of piecewise pop, right? What do you guys call it?
We just call it piecewise
Piecewise
function.
function.
Yeah.
Two different functions technically.
Oh, it's not
So-
continuous.
Yeah, what this is not continuous, right? So this should be a kind of discontinuity that's happening. You guys have a word for that?
Like a break, maybe?
Yeah, kind of. This is called a jump discontinuity. Okay? So
So that's a limit that doesn't exist.
this is a limit as I tend to A that does not exist. You guys see why?
Yeah, you can.
Because where could I put the L, right? Like I might try to put the L here, right? But then if my epsilon's really small, there's no way to get in there. So I might pick one end or the other, right? But if I pick the top end, then there's always going to be some stuff that ends up down here. If I pick the bottom end, there's always going to be some stuff that ends up there. It's just not going to work. What's up?
How do like the plus and minus superscripts play into that definition? Like where you approach it from the left or right? Does that change it?
Yeah, so I'm not gonna review too extensively plus and minus superscripts, but if you do a limit from the left, right, that exists here, and so does a limit from the right, they're just not the same. Hence the jump discontinuity. You guys all cool with that? You remember those? Limit from the left, limit from the right? Okay, let me give you the Calc 3 version here. So the Calc 3 version is harder because there's more than one side to approach from. Okay? But I'll just take this whole thing and modify it. So what am I going to do in Calc 3 that's going to make a difference here?
Approaching
X.
X equals A, Y equals.
Okay. Maybe I should rewrite over here. So I'm going to go like this. I'm going to say, okay, there's going to be a limit still, right?
Yeah.
But now it's going to be of maybe a point, right? This doesn't have to be a 2-dimensional point. This could be a 10-dimensional point. Doesn't actually matter. But that point's going to go somewhere, right? So that might go to like A, B, say. And then there should be a function of those points. And I'm going to say this is L, right? So this is what it means for a limit to exist, right? If for any epsilon bigger than 0, right, for any error, there is a delta bigger than 0. What's the only difference I'm going to make here? Such that if
You make that bottom thing, but also one for Y's.
yeah, it should be a lot like this bottom thing, but also maybe one for y's, right? And then that at the end. You guys see that?
Oh, so it's just two different x minus a and then y minus b.
No, so it turns out that's not enough.
Is it vector?
So what you need, you don't want to make a square here, you want to make a circle. So what you do is you just say, such that if the distance, right, from x comma y to a comma b is, and I'm writing this out awkwardly, is less than delta and bigger than 0, right? And the reason I'm writing this out awkwardly is I just don't have a nice symbol for this yet. But really, there's like souped up absolute value bars that do this, right? You just like put in the point you're talking about and the point you're going to, and then you put souped up absolute value bars, and it's between 0 and delta, right? So the picture there is that you have some point A comma B that you're talking about, right? And you make a circle. That circle's of radius delta. And your x comma y's have to live in there and not actually get to the middle. You guys cool with that? That's really all I mean by this distance, less than 0 and bigger than epsilon, or and bigger than, sorry, less than delta and bigger than 0. So then what? So that's saying if my inputs are in this little punctured neighborhood, then my outputs are,
Less than epsilon.
yeah, they better be close to L. Better be within the error bars, right? So I just say then absolute value of f of x minus L is less than epsilon.
Should be fxy.
Oh yeah, good. I screwed up, thank you. Should be f of x and y, right? But it's practically the same thing, right? Really, you want to go through this thing and just slash out the x's and put in points, right? Otherwise, it's exactly the same. It's an error in the output, and you need to get within a certain error in the input to get in there. Cool? Question, Steels? Okay. Where did my little shapes go? Okay, have you guys all had a chance to look at these? Okay, so I'm going to pass these around, but these are two little shapes, right? These are supposed to be surfaces. The side with the roughest edge goes down. Okay? And what I want you to notice from these is that there are multiple ways for this to break in 3 dimensions, and they're a little bit funkier. So what I mean by that is you can't just approach from the left and the right anymore, because there isn't a left and a right anymore. You guys all see that? So do you want an example of one of these? Let me give you an example of a function where there's a broken limit. Okay, so let's take the limit x and y tending to 0, 0 of xy over x squared plus y squared.
Yeah, that could work.
You guys all good with this one? Okay, so this is like x times y over the radius squared, right? You guys all see that?
Yeah.
Okay, so, and the absolute dumbest possible approach is the approach I recommend here. The first thing you should do to figure out whether this limit exists or not is just play with it a little bit. The dumb thing you could do is just try to plug in 0, 0 and see if it's a continuous function, right? Like, what? What do you get?
I'm getting 0 over 0.
Yeah, if you plug in 0 over 0, you get, or sorry, if you plug in 0, 0, you get 0 over 0. That clues you in that there might be a problem, right? Is this problem irrevocable? I don't know, maybe not. It might be fine, like it might just be a little hole, right? Okay, let me try this. what if x is 0, right? So that's really me wondering about the limit as 0 and y tends to 0, 0, right? With this same function. Oops, x times y. So if I'm just thinking about this, well, if x is 0, then this is 0 over y squared, right? Which is just 0. Right?
I mean, as long as y does not equal 0.
Yeah. But even the limit's 0, right?
Yeah.
You guys see that? Okay. What if, I don't know, what's your next one?
If y equals 0,
Yeah, if y is 0, you get the same thing, right? You guys all see that? Okay, what if x is y?
You get 1 over
Then I'm looking at like x squared over x squared plus x squared, right? You guys see that? That's x squared over 2x squared. That's 1 over 2. Right? As long as x isn't 0. But I'm not allowing x to be 0, right? I'm just going towards it. I'm not actually getting there. Hence that 0 is bigger than the distance, right? Or 0 is smaller than the distance, rather. You guys all see this? Okay, so what does this tell you? That's this surface here. So that's if you walk in from one direction, right? You get to 0. But if you walk in from another direction, you get to 1/2, right? But you're getting towards the same point, so they're stacked up. You're not going to get that to work. That's like that jump discontinuity we had.
oh, is that why there's that that massive dent in this?
Yeah, that's why there's that dent in this surface. You guys all see that? Okay, it should be noted, there are many, many ways to make those dents. Do not get attached to the idea that you can get at all of them by walking along lines. Okay? You cannot get to all of them by walking along lines. They do not all work that way, I am afraid to say. The only way to establish whether the limit actually exists in Calc 3 is with a crap load of work. You have to actually go through this whole definition thing and see if you can get it to work. Okay? In Calc 1, you can like wave your hands at it a little bit. But here, there's no way to wave your hands at it a little bit. You can't try all the directions. Because it's not just the directions that matter, it's the paths too. You guys all see that? So like, it might be that everything seems fine until you walk in along y equals sine of x to the 4th. Right? And that path all of a sudden causes a problem. Cool? But you can't pick up all the paths. So you have to do something a little more advanced. Cool? All right, we'll talk more about this after you guys have had a little chance to play with this, okay?